All right. Welcome, everyone. We are on part 5 of our Creating Dash Proposals from Webapps series. We've got Niles back. How's it going, Niles? We've got AJ back. AJ,
Ray of
Niles.
sunshine.
AJ's in a great mood today, by the way, everyone.
Yeah.
No, I was in a good mood until Ryan asked the question that I thought we answered before we even started on this. And then I'm like, wait, what do you mean you don't know the answer to that question? That was the whole premise of that. Yeah.
We'll get into that. We'll get into that a little bit later.
All right.
Niles, do you want to give everyone the good news from since our last stream?
Sure. So, yeah, I've been working on the same thing as our last stream, which is make it so we can properly serialize and apply a double shot to a governance object. And yeah, we were a little fuzzy on how that was supposed to work because yeah, the code is very creative. It's like it does kind of a hidden thing that we couldn't tell just by looking at it or even using my IntelliSense or my language server tools. And so yeah, I want to share my screen and I can show how I hooked up a debugger and I can just show me stepping through it real quick.
Yeah, that'd be great. Let's see. Do you want to go ahead and push present and share your screen?
Sure.
I am looking forward to seeing this VS Code stepping through the C++ code base as well.
Awesome.
Are you ready for me to add it to the stage?
Yeah, let's do it.
Okay.
So over here I have a terminal, and I just did a make recently. It doesn't take that long to build, but where the magic happens is inside of app init. What I actually did, we can go to the definition here, is I actually put basically like our test data in here just so I can step through the get hash. Mm-hmm. And the reason why I actually had to do it this way is because I tried to set the breakpoint on the part where it actually runs when I run it through -CLI. And it ended up, sorry, let me open Discord on my phone just so I can see if you sent me something. And yeah, it ended up not breaking properly when I tried that strategy. So I tried this strategy and I actually got it to work this way. So I can actually show this now. If I hit F5, it'll open up, and you may have seen a flash of the output from before. There's a little bit that happens before app init, and so I just put some lines here so we can see. And
just real quick, do you have, is there, to get this connected, the debugger connected to your VS Code, did you have like a VS Code setting file? I want to just look at that launch file.
Yeah, so this file, this is actually just the command that I was given by XKCD or AJ. But I just put it into the arguments, and then I put the directory of the program and updated the current working directory because we use SRC as our like built.
It puts the build artifacts in the SRC folder as well. Yeah.
Exactly. Yeah. So yeah, that was that. I can do stop at entry. I actually have that turned off right now, but if I make it true, then it will actually stop like
before it even
when it gets to the first line.
Got it.
Yeah, it'll go to the first line.
Very cool.
And then this one is just, I think this was automatically generated. This is just some C++ stuff, so it'll pick it up automatically, I guess. Okay, so back to where we were. So I didn't set this up properly where, oh, it's not going to bring me back. I didn't set it up properly so I have the C++11 folder accessible to VS Code. I think there's a permissions issue, but actually I didn't need to look at like the C++ internals code to do this. So anyways, back to what I was saying. I have this terminal here, and I have our test data. So This is actually nice because it's going to skip the validation check to see if this time is in the past, and it will fail if it is. And now this is in the past. But yeah, so I could just use our test case, pass it into a G object, get the hash, and get hex. And yeah, I figured out this one actually reverses the data right here. You can see it's iterating through forwards, and then it's taking the backwards index derived from that. So, and then it passes it into hexter. So originally there was some confusion about this. So anyways, let me step through it.
Okay.
And yeah, okay, this is what I was saying. So it's showing me it jumped into C++11x new allocator. And yeah, right now my VS Code doesn't have permission to look at that. But anyways, let's start up. So we go into get hash, and this is our familiar code. You can see I had some more prints in here, but I turned them off. And it actually will jump me between these two. I'm assuming it's interleaved in the assembly. But I ended up writing this print statement so that every time we go in here, let me do step into. It's going to go into serialize, and it's going to go into one of these write datas. It's going to coerce it to a span, and it's going to call this write function, which is going to call this write function. And this is familiar code that we looked at before. This is going to write it into buff. And then every time we fill up the 64-byte buffer, we're going to call transform. And transform is processing SHA-256 on a 64-byte chunk. And I mentioned in our private Discord already, but for the benefit of the audience, we found out kind of a peculiar thing about the C hash writer, that the get hash, which I modified to have print statements, and get SHA-256 and get cheap hash, we found out that this one, it says it computes the SHA-256 hash, but this actually is just taking the data. It's already computed in here. So the SHA-256, it's already in this S table, and it's just writing it in, basically. We do write in padding. So like if we didn't fill up a full 64 bytes and we still had to do another step for it, it will do it here. So there is kind of a finalization step in that sense. But if it's already in a state where you already like finished it, then it will just return it more or less. It'll just write the data in. And then get hash will do a double. And then this one was kind of peculiar to me. It's get sheep hash.
Get hash also actually does the SHA again, right?
Yeah, so it will do it one more time, and it will finalize this one if it wasn't already done.
Okay. So
the first one, the original one that we already did. And then cheap hash will actually just do get, it'll do get hash, and it will just take the first 8 bytes, little endian. So anyways, let's go back to stepping through it. So yeah, you can see I just put it in a string here so we can print it out as hex. So this was printing the revision, and we'll see that again when we go back up. But yeah, this is doing basically what I said. We have a 64-byte buffer, and we're filling that up. Every time we fill it up, we're going to do SHA-256 on those 64 bytes. And yeah, you can see we jumped into allocator, and now we're back. So we were just doing revision. Revision is 1. This is 1 in a 4-byte little endian representation. And then we do time. I could jump through if you want to see it again. But yeah, this is the number in little endian 8-byte form.
When it was going back and forth in like down a line, then back up a line, was that you doing something weird, or was that just that's actually part of the sequence of how the code tells it to run?
Yeah. So I think what probably was happening there, and this happens a lot, is the compiler, for performance reasons, will interleave instructions. Now, when it comes to debug code, it normally shouldn't, but compilers, they pass code through a lot of different passes. And so, yeah, things can get jumbled. And so I think that's probably what was happening, which is like you had one piece that was doing something for this, and then you had another piece that was getting ready for this, and then we jump back. Or it also could have been like a mapping issue sometimes the mapping is not entirely faithful, especially when macros are introduced. And so sometimes the tool can be a little confused. But yeah, that was some kind of artifact that we were observing. I'm not exactly sure what that artifact is.
Okay.
If I actually wanted to spend the time to delve into the assembly, maybe I would see it, but I don't want to do that right now.
I've stepped through JavaScript code, and so I know that it just goes usually from top to bottom. And I didn't know if there was some weird thing that you were stepping back a step, but you're saying no, that's just some weird artifact. Okay, so
yeah,
let's keep going, and I'd like you to step into it one more time. Just
sure. So this is actually the big one. So we're going to step through this one because this is pretty obvious how to do this, and we got it right just by guessing. This one was a little harder. So I guess I'll just show you. First, we do the hex, and we're showing a bunch of stuff. It's just doing like span stuff. It's getting the data, getting the size. And then this is decoding it into hex. So this is relatively straightforward. I think a lot of people understand this. Let's actually go up.
Okay.
And now we're going to hop into this line. So this was the critical one. So when we serialize this string, it's actually going to take us into right compact size. Now
wait, how
I don't know.
did you get there? Is that in the serialize macro?
So it must be, because the last thing it showed me, I went through it a little quick. It showed me a C++11 library thing, which again, my VS Code doesn't have permissions for that right now. But yeah, it just jumped into here. And it's not completely clear from reading the code how that happens. But yeah, I think it's one of those macro things.
Yeah, there is a macros called serialize methods. And that was one of the things that I couldn't follow, but I was assuming had something to do with this.
Yeah.
And
so this is a right compact size function. And it takes in the size, the number of bytes you want to write out. And it has this, what's the word? It has an arbitrary length encoding for the size. So the idea is if you could encode it in just 1 byte, you want to do that. But if it's too large, you need to encode it in 2, 4, or 8 bytes. And the way that we do that is we say, okay, we're going to make these numbers special. So we're actually going to cap how much we can fit in a byte. So it's actually going to be 252 or less. And if we see 252 or less, okay, that's the length. Otherwise, we're going to write 253, and 253 would tell us that we need to read 2 bytes afterwards. And if that's too small, then we can write a 254, and that tells us to look at 4 bytes. And we're going to write into the next 4 bytes. And if that is still too small, we can write 255, and that is going to tell us to write out 8 bytes. And so that was the secret sauce that we were missing from before. And in this case, it happens to be we need 2 bytes. So we write that out. I guess I could jump in here if you want to see, but it's just what we were already looking at. It goes into the same right function. And so this FD is 253. And this is just the number of bytes. So yeah.
And I had suspected that this was relevant, and I'd actually tested it with that. However, I thought that I had matched the hex encoded JSON against the log message. In fact, I had not. So I did not realize that it was reversed, because when you eyeball it, it looks very similar, because whether you read it forward or reverse, the first few bytes of like curly bracket, quote, like they're the same, whether you're looking at it forward or reverse. So if you just like pick some random place and it's got quote, colon, quote. So anyway.
So, okay, so actually here it is. It didn't show it to me the first time I jumped in, but now it's showing me. So this actually is the string one. So yeah, we're calling this serialize function on a basic string, I guess, which I assume string implements this under the hood.
I think that whatever object is, so if you search for serialize methods, I'll post this in the chat so you can see it. If you search for serialize methods, then you will see a place possibly where the object class is passed into serialized methods, and I think that that's what gives it that template type, and then which type of serialize it gets, because it has a different serialized method for string and for int and for all that stuff.
Hmm.
So I think that
Yeah,
that's
so there's SIR right here, and SIR gives us the right compact size and right fixed bit set.
yeah.
That's an interesting one.
So yeah,
There's
if
multiple
you're
SIRs though,
looking
yeah.
in the code, you can't find it because it doesn't exist until the macro executes.
Hmm.
Okay, so should we keep
So
stepping
yeah,
through?
I just want to run through this. Let's finish this out. So let me open up that terminal again. Yeah, so we got this hex data. Okay, this is the real data. This is so this is showing the hex of the hex data, just so everyone knows. It's a little confusing. But yeah.
Double hexabyte.
Yeah, it's double hexabyte. And then, okay, so this one, we also had to ask ChatGPT originally, but now that I did this, I actually know for certain that my guess was correct on what this does. So let's step through this. This is a serialized methods one as well. So I'm doing step into every single time just so we can see what's happening. So this is making a span. Okay, now we're going to call write. And what are we writing out? We're writing all zeros because that's the default data for the master node. We're not actually using that out point, right? And then, okay, let's go back out. And why are we in there? Okay, so it didn't even bring me back. It just brought me right in here. So yeah, this is the default data that's inside the master node. Okay, and then for these two, we actually write out another null byte for this one, and then another 4 bytes of this. So these are just dummy values. It's there for some legacy reason. And yeah, we can see in here. I could have stepped over the whole thing and you would see it, but I just want everyone
Wait,
to
go
know.
back to the dummy values real quick.
Yeah.
Okay. Master output.
So
Okay.
yeah, so this is going to write out 1 byte of zeros. And then this is going to write out, I'm just going to hit F10. We'll just go over it. It's going to write out this thing again. So yeah, so I actually could tell that without having to delve into it, but definitely this one was a kicker. And then when it comes to this is the same deal. So we have to write out a compact size, but you can see if it's empty, then we don't write out the actual data, but we still write out the compact size. And what's the compact size? It's 0.
Right.
And so we need to write a byte of 0 right there.
Right.
So that's what we do. So I'm just going to jump back out. And then, yeah, so you can see we wrote 1 more 0.
So this is great because now we have the never before documented structure of what a G object actually looks like.
Mm-hmm. And then we call get hash for this one. And this is, it's doing string initialization stuff. Okay, so inside of finalize, I guess I must have hit it one too many times. Yeah, so you can see we're writing out this data here. And this is actually just padding. We pad it so that there are 8 bytes left. So then we can write size_desc in as a big endian integer, which is the number of things that we're actually hashing. And you can see that at the end here. And originally I put this in the JavaScript code, and then it didn't work. And I actually realized that we don't need it in the JavaScript code because the crypto library will do that. So the crypto library does this for us. Because that's part of SHA-256 is what's happening here. And then, yeah, I print out the first SHA-256, and then another one happens. I'm just skipping over this. And then this is the second one. And there you go. And you can see this is what we had before. So we had it in reverse order before. I don't know if we showed it on the stream, but it was A9, F2, D0, 7.3, C2. So yeah, this is the right one.
So can you bring up your at some point when you're finished with your train of thought, let's bring up the gists that AJ started and that you modified and that shows success as well.
Yeah. So yeah, this is what we were comparing against before. This is the reverse of this.
Yes.
The bytes are reversed, not the nibbles. But yeah. So I think we're done with that. Actually just stop it right here because I didn't even do anything dangerous to the node. And I believe the most up-to-date one that's the same as the gist should be right in here. And let's see if I can do a split screen on this, maybe.
Prop.js is living in your code base now, but that's just basically a copy of your updated gist that we had from the last
Should be the
stream.
same thing. Yeah,
okay.
Should be the same thing. And I forget, I don't want to do this one. I don't want the default shell on VS Code. It's not in my normal setup where I use Codium. I have it set up properly, but I don't have Node in here because it's something. But I have a Node over here, so let's just do it this way. Let's cd into the JS version. Go up, JS version. And then let's bump up the font so we can actually see it, I guess.
Thank you.
Let's make this the full thing and go like this. And not that. Node. Prop. Okay. So you can see, I'm going to make it just a little smaller so we can see. This is the same thing. And so we have the hash parent, revision, time. This is the header byte, that's 253. This is the length of the hex JSON, I guess.
Mm-hmm.
And then this is the hex JSON. These are the same. And then we have the master node outpoint hash. This is just default. It's all zeros. Master node outpoint index, which is all Fs. So that's these two. And then we have a dummy byte and a dummy 4 bytes here. They're the same. And then we have the signature length. And then we have our 2 hashes. So you see the first hash right here. And then this is the second SHA-256 right here that we end with. So there you go.
And you got the sweet, sweet victory line.
Yep.
Meaning it
That's from AJ, yeah.
Yeah.
So yeah, if we want to look at the code, we can, but yeah.
Sure, yeah. Let's get it on screen. I think you might have already, but just scroll a little.
Yeah. So I wrote this code that will get the compact size extra offset, and then it will actually write it in. We had a little bike shedding argument about that earlier, but we need this because we have to use a uint8 array. Well, it's the easiest way to do it, the best way probably. And we need to compute the length up front because these things don't dynamically reallocate. And so we want to figure out what the compact size will be from the get-go. And it happens to be that a hex JSON encoded in UTF-8 will have the same length as when it's encoded in UTF-8 because it's hex. So that means it's just those characters. And so we can actually just take the length and we can compute exactly how much data we need in our buffer. And unfortunately, there's kind of a weird API in JavaScript that maybe some people already know, but you can have a data view and then you can operate directly on the uint8 array. And so we actually use both. So we can use bytes.set to put a buffer in there. And then we can use the data view to put individual like integers in there. And so you can see how this mirrors the other code. So before we had to write in the hash parent, then the revision, then the time. And this one was 32 bytes. This one was 4 bytes. This one was 8 bytes. and then we write out the compact size, and then we write out the actual hex encoded JSON, and then we have the default master node outpoint data here. Okay, yeah, so this one is just writing out the zeros. This one's writing out the index. So this was the hash, this was the index. And then I have the dummy values for backwards compatibility. And then this is the VCH sig size, which is 0. And then we don't actually have to write it out. We don't have to write out any zeros or nothing because that's what it said in the code. And then yeah, our test is pretty straightforward. We just have the test data, which is the same as the C++ one that I showed at the beginning. And I have this block here, which will just print out the different chunks from hex bytes. And so I just say, okay, hash parent is the first 32, then 4, then 8, 1, whatever that computes to, whatever that computes to, then 32, 4, 1, 4, 1. And yeah, so it'll just print it out so that we can get this nice understanding of what's going on. But yeah, from there we just do SHA-256, do it on top of that, and we're done.
Awesome. All right. Well, we've covered a lot in 25 minutes already. So what I wanted to do, either now, like right now, or if there's something else that you two wanted to discuss before we leave here, after that, then we would go to our Dash Hive libraries that AJ has written, because part of the submission process it's actually part of the prepare process in the C++. It requires that payment of a 1 dash collateral payment to prepare the transaction. And so want to look into the JavaScript, like how we would do that in the JavaScript side of things. And admittedly, part of this whole exercise, Niles, is to get you familiar with what we have in the Dash ecosystem, both on the Dash core group side of things and on the Dash incubator side of things. So yeah, this has been very good to get you familiar with the C++ code base, how to write it, or how to modify it, build it, compile, and step through the code. So this has been useful for this exercise, but potentially useful for other exercises in the future, for other things entirely. But I also want to get you familiar with the Dash Hive stuff, Dash Incubator, like AJ and Jojo Bytes corner of the Dash Incubator. We put a lot of that work under Dash Hive, github.com/Dash Hive. It's one word, no hyphen. So I want everybody's blind now from your
Sorry, I use a e-ink monitor a lot, so.
So AJ, do you want to? Can you give Niles a run through the? I'm not sure if the pin. If it's best to go with by looking at.
I'll do it. All right. So Dash phrase manages two things: generating 12-word phrases and hashing those into seeds, which is based on PBKDF2, if I remember correctly. That's the two things that Dash phrase does. It manages the wallet itself, which is the 12-word phrase. Go back.
Okay.
Once you have that seed, then Dash HD takes that seed and a derivation path and basically iterates over it a number of times to generate hashes of the seed, and the hashes function as private keys, because a private key is just a number, well, bytes.
Can you bump up the font, Niles?
It's the private key is just bytes that when you call the toPublicKey function on it that plots it on the elliptic curve doesn't fail, which is basically any set of random bytes. There are a small set of random bytes that could potentially not have a valid plot point, but I think it's like null values or all F values or something like that. Anyway, point being, that's what Dash HD does, is it just follows the hierarchy to deterministically, and that's what it is, a hierarchical deterministic, HD, hierarchical deterministic, just takes the seed and then uses the seed as basically like a random number generator, except that it has a path component to it, and that generates keys. Keys are what hold money and what can send money and what can sign money. So,
and how's that different from a wallet? A wallet is just where you get the keys from through this pipeline you're talking
a
about.
wallet is the 12-word phrase.
Wallet is a 12-word phrase.
Yes,
So you
the
put that
wallet.
in here, and you get out your
seed, and then dash
Your seed.
HD takes the seed, and it can derive the keys.
It
So you
derives
can
a
also
bunch of-
you could just generate random numbers, and those are keys as well. But then the problem is that you don't have a wallet to hold them, and so you would have to just create files, and every time you generate a random number, you'd have to store it somewhere, and then if you ever lost that file, there'd be no way to get it back. Whereas with a wallet, 12-word wallet, you can print it out, put it in your safe box, and you, like, if you ever lose if the software ever messes up, all you need is the 12 words to get everything back.
Yeah. So Niles, the dash HD, the whole purpose behind that is like AJ was just saying, like, if you can't interact on the Dash or Bitcoin or any cryptocurrency network, you can hold funds in public private key pairs, and if you can just create them disjointly, like randomly, but Dash HD gives you a way to create a bunch of those key pairs, but you can derive them all from one seed phrase that you back up. So that's the overall purpose there. Keep going, AJ.
All right, so then there's dash keys. So dash HD gets you to the point where you've generated the random number. It actually does have to use dash keys because there is kind of a cyclic nature. You take the random number, you turn it into a key, you get the public part, you take part of that, you mix it with part of the hash, and then you get the next sequence in the chain, or you take that and you mix it with the private part, and you hash that, and you get the next part in the chain. How that works is not really that important for right now. Just dash HD derives the keys. Now, dash keys is what actually does the conversion between the different encodings of the keys and gives you a interface to, well, actually, you could just use SecP256K1. So dash keys is what puts the keys in different formats. It's more about encoding than anything else, but it does have some convenience functions. The main thing that actually works on the keys is SecP256K1. SecP256K1 operates on the bytes. So if you scroll up to the top there, you'll see the most common representation for a key that you will see in applications is the WIF. That's the actual key. And then the address. The address is a hash of the public key.
WIF is wallet import format.
Yeah, it's kind of a misnomer, but it's the private key. And
it's the private key, but encoded in a way that the standard is that if it's
it is
standard, then that's how wallets are built to work with them.
Yes, it's just the human readable encoding, the base 58 encoding of the private key. The address is the base 58 encoding of a hash of the public key. So it's not the public key itself, it's a hash of the public key. Base 64 encoded.
Base 64 or base 58?
Sorry, base 58. Sorry, I misspoke there. Just words coming out. Okay, so that's what this manages, is going between the different formats. The byte format, some intermediate representations that will elide for now but are referenced in the documentation, and then the human format, which is what you see in your applications and what the QR codes contain.
Okay, so...
And then there's SecP256K1, which has the sign function and the toPublic function, and the I forget what it's called. I think it's called the add, or they call it something. Basically, it's a function that just translates the key from one part of the curve to another part of the curve that allows you it's part of the key generation process. By translating the point from one place to another place, you get a mathematical relationship between the new point and the old point that can work forwards but not backwards, so it kind of functions similarly to a hash. Well, actually, it can work backwards if you have enough information. But the idea is that it is useful in derivation. So that's basically the three functions that are in there: is sign, using just the private bytes, to public, using the private bytes, and then translate can work either, I forget what it's called. It's like add special. I don't know. I can't remember off the top of my head, but it can take either a private key or a public key. And one of the interesting parts about it, if I remember correctly, is that if you add to a private key, then you can add to the public key, and you'll get, it's not really an add operation, but they call it add because it is semantically similar to how an add works, but applied to an elliptic curve. Anyway, that's more than enough for that. So that's everything that you need to do to basically do stuff locally without ever interacting with the network. Everything that you ever want to do with a wallet. To clarify, you cannot store money on a key. Money is only stored on the blockchain in a transaction. But when you check an address against the blockchain, you can reveal that money is allocated to that address. Nothing that you can do locally, no hardware wallet, no software wallet, none of that has anything to do with money in the end, other than that it can sign a key to give permission for money to go somewhere else. But money, there is no file that you can save that represents money. The blockchain, well, I guess the sum total of all of the aggregate operations of the blockchain is what means money exists or doesn't. So -tx is how to create a transaction. So how to basically sign a message that says, I allow money to move from my aggregate sum total that's represented by this particular coin, where a coin is a transaction ID and a transaction output index. That's what represents a coin, which is a money. The -tx is what encodes that, it signs and encodes that, so that you can broadcast the transaction. If you broadcast the transaction and the network accepts it, then the money then goes where you say that it should go. In the case of Dash, that typically happens instantly because there's not enough traffic to overwhelm the allocation for instant transactions. So that's what -tx does. And then the next layer would be -rpc. And -rpc is what allows you to take the bytes of a transaction and send it to a full node or master node to become a message for the network that will go on the blockchain. So there is I can't remember the name of it right now. I think it's submit raw transaction or something of that nature. Okay. But there is an RPC that will let you do that. Also, -site lets you do this. -site is a wrapper around the RPC that has a very high level of abstraction.
You said -site?
Yeah, -site. Like as in I see you, -site.
Search in the GitHub, the -hive GitHub search.
Go for it.
So -site is a crappier version of -rpc. Because at first I didn't know that the RPCs are just HTTP calls, and so we were using Insight for everything. But then once I actually found out that the RPC calls are HTTP, there's no need for Insight other than for the statistical analysis and the UI. But in terms of being able to interact with the Dash network, -rpc is a much better choice because this renames things in weird ways, like TXID with a capital I rather than a lowercase I. There's some stuff like that where it's just like, it's different, but it's neither better nor worse. It's just different. So I'd recommend for new code using -RPC. The one downside to that is that you do need to stand up a web server in front of a full node that will proxy the allowable or the public RPCs. And we do have that as -site server. The reason for the naming of that is that it's in a PR right now. It's not ready to be published yet. There's a few changes that still need to happen for it to be public. But anyway, so if you wanted to get started in the lowest touch way possible, -site.js is the better thing to use right now today. But as soon as we have the -RPC service published and publicly available, -RPC would be the better way, because then you're not dealing with various layers of abstraction that are simply different. It's not like abstraction and like, oh, this makes this so much easier. It's just, over here it's called TXID with a capital I, over here it's called TXID with a lowercase I, over here it's called output index, over there it's called vout. Over here, it's called input index. Over here, it's called VN. It's like tomato, potato.
Okay, so that's the high-level overview of what we've built in Hive to do a lot of the transactional and key management stuff. So the reason that that's important is because part of the proposal submission process is making a transaction that uses the op return. So AJ, do you want to give tell us what you think would be a good roadmap to follow to take what Niles has already done with the serialization and hashing stuff, GObject stuff. Where do we go from here?
Okay, so the next simple step is just to create a transaction object to get the TXID. So that would be just part of the prepare before you don't need to submit anything. You don't need to submit a transaction. You don't need to submit the GObject, but just use -tx to create the serialized transaction and get its ID. That goes into the governance object. That is part of the governance object that is broadcast on the P2P network, which is a TCP network, not an HTTP network. And then what needs to happen is, once the person has paid for their proposal, so let's imagine a web interface where they fill out their proposal, they hit save, it shows them all of the information that will be submitted on the network, and then they click pay to submit, pops up a QR code, they scan the QR code, they click pay, and then it will have to spin for about 2.5 minutes, because I think that it has to actually wait for a block. I could be wrong. I think it has to wait for a block in order for the collateral to be valid. Maybe it works with instance.
That's something that we will experiment with that. If it recognizes it with an instant send, great. But I think you're right. I think it does require one block at least.
Yes, because I believe that the method that gets called to read the GObject is one that requires tip synchronization.
Yeah, and
what does that mean?
We can always submit a proposal to change that if we want instant send to recognize it if we wanted to, but that would be something that we would do afterwards. Anyway.
Yeah, I think that's more of a code issue than it is a network or protocol issue. I think it's more the version of the code that we have was written that way at some point in time, maybe even before instant send was a thing, and probably hasn't been updated since.
Yeah. One thing that we discussed before we got on real quick was we need to figure out what GObject submit is actually doing.
And while we were reviewing, I figured that out.
You figured out what GObject submit does?
Yes.
Okay. So why don't we go through the C++ just give us something to look at while you're explaining that.
It's like 10 different files, and the end result of it is that it does the same thing we're doing with CoinJoin. So what we would do is we'd take the CoinJoin code. So it's good that we did this now, because now I know that that part of it needs to be abstracted out from the CoinJoin process, because I didn't realize that this was generic, or what to degree it was generic, because I was only looking at it from the myopic view of CoinJoin. But we connect to a masternode the same way that we connect via CoinJoin. It's possible that we could connect to any node, but I think it makes sense to connect to a masternode, because then it's going to be exactly where it needs to be and propagate exactly how it needs to propagate.
Mm-hmm.
And we would submit the collateral transaction to the masternode. No, we'd submit once everything is ready. We already have the transaction and the TXID and all that. We would submit the transaction over either RPC or Insight. And then we would need to proxy the same way that we proxy for CoinJoin. We would need to proxy the G object to P2P, or we would need to have a PR in -core to expose it as an RPC. And then we could use -RPC. But in any case, the part that is not clear is the way that it is serialized, but we can use the same trick that Niles just used, stepping through with the debugger. I have in the Discord chat the like 10 different function calls that this passes through until it gets to the part where it sends the message. So we could look at where the vinventory other to send .pushback is called, and we could log out what the bytes are at that moment. And there is going to be some header information that's added to that. We already have that in the CoinJoin code. But those bytes that we get in that vector, I believe, if I read the code correctly, which I may be slightly off, but I'm definitely in the ballpark of where it is. Those bytes are the bytes that we need, and we can look from those bytes and figure out how it was serialized, because they are going to be either a big Indian or little Indian representation of the object that we already have. So it's going to be similar to what we just did. It's just going to be some different properties, including the TXID that we just did that previous step for. So it's kind of like,
I think it's all exactly the same, isn't it? Like as far as the RPC command, gobject prepare and gobject submit. The only difference is you append that what's returned from gobject prepare onto the end of gobject submit. But we'll look at that in a minute.
Don't know that that's true, because I don't see that in the documentation, and I have not observed that in the code.
We'll look at the documentation. I think it might actually be there.
Could we?
We'll see.
I want to pull up the code specifically.
Yeah, let's pull up the code. Niles, get that ready. I'm going to take a little bit of time to answer this somewhat of a troll question, but I think it's actually a good question. Have you guys programmed a way to get people interested? So the reason that I kind of know that's a little bit of a troll is this is an individual who used to be more active in the Dash community and now is not, and it's kind of trolling us a little bit. But it's a good question nonetheless. And this series is exactly what we're trying to do for that, actually. People get interested in a cryptocurrency when people can make money through that cryptocurrency. It's the same with any economy, actually. People are interested in the US dollar economy because they can earn a living in the US dollar economy. And the only way that we will be able to beat the US dollar economy is if we can get more people adding real value and creating real products, real goods and services in the Dash.
Meaning not just gambling.
Not just gambling, not just hoping for number go up, but actually people say, for example, submitting proposals that in a lot of the same way that somebody submits a proposal to a bank to get a loan, or a VC to get a loan to do to run a business, and that business will then hopefully turn a profit and have customers that want those products that startup is creating, that's what we need to recreate in Dash. And a very minimal version of that is giving people the opportunity to submit proposals to Dash. A lot of the proposals to date have been infrastructural proposals, but I'm hoping, and this is what I'm building towards, is a future where people can submit proposals to create real goods and services, and require Dash payment for those goods and services. And in the same way that people take out loans or give equity to VCs, we can create that same kind of economy and those same kind of financial services in the Dash economy. And I think Dash platform will play a role in that, because that's all data dependent. If you want to create a loan, that loan, there needs to be public data that says what the terms of that loan are, for example. And I think that's going to be probably the biggest and best use case of Dash platform, is these kinds of financial services that have real goods and services behind those financial services, backing those financial services. So it is a bit of a tangent there, but I did want to mention that.
Well,
Creating proposals needs to be easier for people.
Products and services, yes, but the Dash needs to function as money, not as the technology, because there's things that people already want, but there is an actual difficulty in getting the money in terms of both fees, regulation, countries, currency conversion. That is a problem that Dash solves by virtue of what Dash is. But there's lots of services that, like, I've mentioned domains, hosting in particular, because domains do have a fixed cost that there's no way around it, but hosting does not have a fixed cost. The cost of hosting, the reason that things like AWS are so expensive is because they were built on investor money that demands that they somehow 1000x that. And if some service or something was built in such a way that the money wasn't expensive, the money itself was cheap money, not expensive money, then the service would not have to inflate its prices in order to adjust for the fact that the money itself is expensive.
Right. Okay. So, Niles, do you have your screen share ready?
Yeah.
I sent you a link with the things that I was stepping through.
All right. Let's not put it on the show just yet, because I'm going to look at the Discord.
Oh, okay.
Okay,
I sent it in the private comment. The private chat thing link is the same as what I put in Discord.
Okay. Yeah, I think when I actually look at the code, I have the language server stuff, so stepping through it is not super hard.
Okay, are we ready then?
Okay. Yeah, we're ready. Okay, so let's go to G-Objects Prepare right here. And this is on the develop branch, just so people know. So if you go look at main, this looks a little bit different because they put this RPC help manager on there. And so now the functionality is embedded within a function in here. And you have a bunch of information about it here. So just so people understand the discrepancy, if they go look at main, this is going to be slightly different than what we're looking at here.
And just so everybody knows, the culture / convention within Dash core group is not to use main / master. They do not use that. They use develop.
There you go.
So if you want to create a PR, you don't create a PR off of main or master. You have to create it off of develop.
That makes sense.
So I don't know what main / master is for. That might be for things that have been released already. I'm not exactly sure.
Okay. So yeah, this is G-Object Prepare. And yeah, AJ, did you want to say which ones you want to go through, or should we just kind of do high level of these real quick?
I don't want to go through any of that because none of that is relevant to being able to submit it.
Okay. So we don't have to do this, or...
Nope. Nope, that's
this?
all like ceremony wallet stuff.
Okay. Okay, so you want to go to GObject submit?
Yes.
Okay.
The only thing in there that you need is to get the transaction ID, but you do not need to do it the way that they do it. You can just get it from the transaction.
Okay. All right. So
Real
let's go to
quick, before we
GObject submit.
before we actually look at the code, Niles, could you also just flip over to the documentation for GObject submit?
Sure. Oh, it's not. Okay, let's go over here.
Yeah.
Okay. Is there anything
Okay.
specific you want right here?
Scroll down slowly. Here's an example. This is what I was
Okay.
talking about, AJ, where it's the dash CLI testnet, GObject submit, all that stuff. That hex, that's the same as the prepare. The only thing different is that line at the very end, which is the TX ID, I believe.
But this is not related to what goes on the network. I mean, it's related in that the data is there, but this is not. There is not a close relationship between this and the data that's hashed or the data that goes on the network.
Right. Yeah, I understand.
It's
So
not a one-to-one relationship. It is a close relationship. It's not one-to-one.
Yeah. Okay. We can go back to the code now.
Okay. So the first thing we do, ensure any node context, ensure that that node is a chain man. We have a check non-fatal macro here. We want to sync up the blockchain. Okay, now we do node.dmn man get list at chain tip, node.mn active man. We want to check has valid and then by collateral based off of the out point. And then assemble a new governance object from user parameters. So we get the TXID fee and looks like, yeah, this is the fee TXID. And we get a hash parent, same as before. Revision in time, same as before. And so, yeah, so this is the difference. So before this was just the default constructor for uint 256.
I think what that means is that it's the collateral transaction ID. I don't think that it has anything to do with fee in the way that the word fee is used everywhere else in the code.
Okay. And yeah, this is passed in as a parameter into the submit.
Yeah, that's the collateral. Right, that's the collateral. It's not the fee. I don't know why they're calling it fee there when they're calling it collateral everywhere else.
Okay.
Because fee has a specific meaning. Fee means the amount in a transaction that is not submitted to another address.
Right. That's a transaction fee.
Mm.
And this might just be meaning this is the proposal fee. But yeah, I think you're right. It's they also call it collateral in other places.
Yeah, collateral is the canonical term.
Okay. And then if it's a trigger, we do this, but we're looking at proposals. So we validate that it's correct, this JSON. And then we take the hash. And yeah, it looks like this hash probably is going to have to deal with the TXID fee. Although
I think,
where does that data go? Let me go look at that.
Yeah, the collateral TX is saved to the object, if I remember correctly. Yeah, so there it says collateral hash. That is the canonical name, is collateral TXID.
So it goes inside of mObject.
Oh no.
And mObject has it. This is a syntax. Oh, it will tell me where it's going, right? Or no, that's just the name of the parameter.
It's just another meta object abstraction.
Yeah. So it's going in one of these. I actually don't see. Oh, I have to open this one. Here. Goes here.
Yes, so I believe that when that gets serialized, that will be important.
Okay. So we do have a collateral hash inside of this macro here. I don't know how to read this. Yeah. Okay. So it's just going to serialize each one, I assume. If it's serializing in the same way, we already know how to deal with this, right? Because we know how to do this, and this, and this. Yeah, we do. And we know if it's a string or a vector that it needs the compact size beforehand. And so we should be able to get that pretty easily now that we figured that out.
Yes. So this one, serialized method, object, read write, get type. Okay. So yes. So it may be that the same code that we used for serializing before, we apply that same logic to these properties as opposed to the other properties.
Mm-hmm.
So this is going to have the full VCH data, but not as hex and not byte reversed. Or maybe the serialized macro does make it reverse hex.
Well, the JSON, the hex JSON encoding, that wasn't reversed.
I thought you said it was reversed.
What was reversed was when you printed out the hash using the get hex function.
Oh yeah. I understood that was a possibility to be reversed.
So there were two functions. I'm just going to write them here. So hex stir doesn't reverse. Get hex.
Oh, okay. I misunderstood earlier because I thought you were saying that the hex of the JSON was reversed. What's up, Honene?
Yeah.
Cameras lost power, 3 of the cameras. So I couldn't spy on you. So I just was wondering where you were.
Oh, okay. I will check on that because I know that happened.
In the shed, outside, in the backyard, and one other one. I'm not sure which one.
I will have to check and
It
see.
says so on the.
Yeah, I believe it.
Anyways, okay.
Okay. Huh. Our security system's down. If you want to rob me, do it now.
That was the perfect time.
Yeah. Yes, something happened.
So AJ, I'm just reading your message into our Discord group where you said it looks like we would submit the G object in the exact same way that we submit the coin join request. Connect,
Yes.
handshake version, enable INV, send INV bytes, maybe get confirmation rebroadcast of INV, and then disconnect.
Yes.
We do have to wait for the collateral transaction to show up on the network before submitting the G object.
Yes.
So it looks like you've gone through this while we were talking about some other stuff. You figured out basically what the G object submit does. With that understanding, what are your current thoughts on how we implement this from here? Like what do we?
Niles does the same thing that he did before. He uses the debugger to put print statements that write out the serialization to the console so that we can verify that the serialization is correct. If there's not already a get hash somewhere on that serialization, add one in so that we can check that the hash, that we can produce the same hash, because there is the problem that maybe the way that it prints out to the screen and the way that it, I think they should be the same, like, because before it prints out to the screen, the reversing of the bytes happens, right?
So I'm just saying, when you were printing out of the screen, you were calling that function. I'm not doing that now. So I'm just showing it in the right order that it's in.
Okay, well, whatever. Point is,
So,
whether it's reversed or not, you will know because you will print it out to the screen.
Yeah.
So you will be able to determine the actual serialized format as per the network serialization as opposed to the collateral serialization. So we need another function that's serialized for broadcast, which is different from serialize for collateral. Serialize for broadcast should throw an error if TXID, collateral TXID is not set.
If collateral TXID is not set, which is TXID fee?
That's what it's called there.
Okay.
That's the collateral TXID.
Okay. And okay, does any of this stuff up here matter to us?
No, because this is all stuff that this would be implementation specific. So
okay.
When we implement this, we would just pull on our TXID to see when our TXID enters in the tip. Like we could have a WebSocket open to listen on blocks. And then when a block comes in, we could then query to see if the transaction ID is now valid. So as soon as the transaction ID is valid, because it's in the current block, unless there's some logic that says that it has to be 2 blocks or it has to be however many blocks it is.
Do you want to check that real quick, or like I can go to definition for any of these?
I think that can be done off stream because it's minutia. It's not like a big reveal or anything. And if it didn't work, then we would just like wait till the next block and try again, and we'll figure it out. So, and then the submit to P2P stuff. That's what I've been doing as part of CoinJoin. I do not yet have that in a format that I could say, here, Niles, you can use this library. Here's documentation for it, and it'll work.
The submit to P2P.
Yes.
That's actually, that's kind of like a missing piece for me, because I've seen a peer-to-peer library, I think in DCG's organization, but we've never done it in the incubator as far as I know.
We have, because we've done it for CoinJoin.
Oh, okay.
That's what I was saying, is that the CoinJoin connects to the masternode, sends the version request, gets the version ACK, and it's a very specific set of steps. Again, I don't think that because the protocol defines this, but because we only have one implementation of it, and that implementation has not probably been updated since it was written. So there's a very specific set of steps that have to happen in a very specific order, and you can't jump the gun like you can with most protocols. Like with HTTP, for example, you can start sending like the headers back before you finish processing the request body. With the P2P messages, because of the way it's coded, not because of the way of the spec, you actually have to wait for it to process the version message before you can send the data message.
Does it make sense to go over what you've done in the CoinJoin stuff? Go over that with Niles right here and now, or?
Yeah, let me do a quick go over of it. Go ahead and
did we
I'll
want
share my
to
screen.
do anything else with gobject submit, or we want to go straight into that? Because
if you
what I would like, just real quick on this, is if you could say like, what is it exactly we're trying to extract from here?
Okay, so how it gets serialized, but all right, this is the path.
So
go find
hash.
relay.
Right.
Go find relay.
Okay.
See where relay is called.
Here.
Right, the governance relay peerman, and no, that's not it. Where was relay at? I actually don't know which function you're in right now. Are you in add governance object? Okay, so look for add governance object.
Okay.
Oh, there it is. Yeah. So go into that one, and from that one you'll find relay.
Okay.
So, yep. And then, so there you see, whoops, you scrolled.
Sorry.
That's not it. So if you went to the go to definition for the add, then you'd find relay. Okay, there it is. So you got, no, is that the one? I don't know if that's it actually. I don't think that's it. There's a bunch of functions called relay on a bunch of different objects. So the one that we need is, yes, I think this is it. There we go. See, it says relay INV. INV is the serialized format.
One bump on the font, if you would, Niles. Just one. Yeah.
All right, so I don't. Say C, E, and V. So this is where it's got like some macro magic or something. So it's getting a hash, which I think this hash is the same hash as the one that we had before. I can't remember because there's multiple hash functions, but I think that this one ends up being the same one that we already had. I don't think it's. Oh no, because the collateral is different. So if you look back up in, scroll back up. Wait, oh no, you're going so fast. I saw
Where do you want me to
collateral
go?
hash. I don't. No, wait, stop. Go scroll back up. Collateral hash. Oh, that's part of the constructor. That's not part of the hashing. Okay. So then I think that this hash will give us the same result that we got before. Because we're not going to have VCH sig yet because that gets added by the master node.
Mm-hmm.
So
Okay,
you can go back to relay and it has the C, I, and V, and I believe that that's going to call the serialize function. I'm not really sure. Maybe it just hashes it, but the data's got to exist somewhere, so that can't be the case.
So the constructor just writes the data in, right?
Inventory.
Yeah, because
just
these are the parameters. Or sorry, the properties.
So I may have missed something then, because I thought I saw where it was passing in the governance object. Does it not pass it in right here? Relay.
It passes in the hash of the governance object.
So so the inventory message is of the hash, but this is peerman relay inventory. Okay, so this relay inventory has the hash. I missed the part then, so I did not find what I thought I found. I skipped over something because somewhere there should be the object itself. Somewhere the object has to be submitted, and I imagine that it's a similar message as the inventory message, or maybe there's somewhere lower. But the whole thing that I was tracing down is where the inventory message gets sent. So if the inventory message is only the hash and not the data, I missed the part where the data is sent. I thought the data was being sent by the relay.
Okay. Let's look in here just real quick. So this is just a bike shedding on the iteration. Let's see, we got...
I don't think that this is... I think this is too deep. Because you're looking at the generic implementation, you're not looking at the G-object implementation. So I think you need to go back to the add... Oh, you know what it might be? It might be the notify governance object. I thought that the notify governance object was just being optimistic and saying, broadcast the message to myself, but that might be broadcasting... I didn't think that maybe it is broadcasting through the ZMQ. And we do have the library for that as well. So if it's broadcasting, so there may be 3 broadcasts. Blockchain broadcast for the collateral TX that has the object hash. Inventory broadcast that has the same object hash that is in the collateral. And ZMQ broadcast, which has the actual data.
Okay.
But we do know how to
back
do
up.
the ZMQ. So there was the add.
This is add governance object.
Yeah, an add governance object has the... I mean, you just look at it for yourself for a minute and, orient yourself. But there's 2 things it does. It adds governance object and it notifies governance object. An add governance object may... I missed the part where it sends the data.
Here's a relay. Master node. Well, there's a rate buffer update. This checks. This sends notification to script/ZMQ right here. Is that what we're looking for?
So maybe.
Notify governance object.
Yeah, so
And
it may be
does-
3. If it's 3 channels, then yes. If you also don't see anywhere else that the object is being sent, that must be it. And so then we need to proxy the ZMQ broadcast as well. And we have ZMQ broadcast, I think. We certainly have ZMQ subscribe. I think we have ZMQ broadcast.
What is EMQ again?
It is a hype synchronization protocol that was popular at the time that Bitcoin was invented.
Okay.
I don't know if it is used much anymore, but it's one of those things like CouchDB and Mongo that like just had a bunch of marketing and then everybody started using it regardless of whether or not it solved the problem for them.
Mm-hmm. Okay. Well, I do kind of want to just look at what this does. Okay, so
Yeah,
this
go
just
ahead.
gets the object inside, which is this again. And so that gets dropped into notify governance object. We have make shared. I'm not a C++er here. This is some kind of a shared pointer. It's an object that's owned by a shared pointer. Okay. And then, yeah, let's open this up. So this is C main signals and our object.
That one looks like it's only doing the hash as well. NQ and log event. Maybe.
Okay, this recursively calls this notify governance object.
That
And
one looks
then-
like it's got a real object inside.
Yeah. And that has this data in it.
Right.
Yeah.
Which we suspect
So-
is serialized in the bit that you just found.
Yeah. And then we also have the hash of it here as well.
And that.
Oh, this is just for
NQ
the log, right? That's just
Well,
for-
maybe. But yeah, I don't think that that's what's broadcasting to the network. I think that that's using it as a key value pair or something. Or just using it to
What?
log. I don't know.
Oh, this is a virtual. Come on. Can I click on this and it will give me definitions? References? That's virtual. Okay, we got a couple. So here's this one. I'm going to jump through into here. So this is another.
It's very important that every object have a function of the same name. You want to call them in a chain, and you win if you have the longest chain.
All right. Here is, this looks like an H file of it, right? Is it H file? Yeah. Okay. So here's, oh wait, this is just another notify governance object.
We're
That
getting there,
returns True.
but that's the abstract interface virtual class. You got to go find the real one now.
Okay. Let's do a plain text search. So this is what we already saw. That's what we already saw. We saw that one. And that's just a definition. This was what we came from. This is the virtual default thing that it does, right? Another recursive call. Okay, here's some code.
Hey,
So this does
code!
something. All right, we got something that does something right here. So we get the hash again. And yeah, this hex,
Key
this
value
is what I
pair.
was talking about. This will be reversed. And yeah, so we make 32 bytes, and it looks like we're writing it in backwards into the buffer. And then we send this data. What is this one?
That's the hash.
Hash governance object. So, okay, so you're just saying that it's what kind of message it is. So yeah, so you take the data.
But the data in this
hash.
one, the data is the hash, or is this one
Right.
the data is the object? So there should
Yeah,
be.
the data is the hash.
Okay,
Reversed.
so there might be. Okay, so this one is hash governance object notifier, and I think we want governance object notifier without the hash. Because the object's got to go somewhere.
Right.
It can't just be hashes.
Let me just see this real quick. This is just a send message. Okay. We can go back.
I think it's going to use the hash as the key and the data as the value. I thought I saw that somewhere, but
Okay, so yeah, this object has all of that data. Okay, so it's passed into here. And what does this mean? Is this is some kind of iterator? Or
it's an auto.
yeah, but what is this? What is this doing?
Ask Jippity.
Okay, it's a lambda expression.
Of course.
Okay, so yeah, it's a function. It's like an anonymous function. Cool. Right. So it doesn't even have to. Okay, so yeah, in JavaScript it would be like if you had a function object this,
var
and then you
event
actually
equals.
called it like this, I think.
I don't think it's invoking it. I think it's just defining auto event.
Just defining it.
Auto event means figure out what this is based on the other side of it. And the reason it's doing an auto for that is you could like because the lambda is its own type. And I believe that every lambda is its own type. So even if you had the same lambda twice, they would be different types. But anyway, so what it's saying is that it's going to enqueue that function to be called later.
Okay. Here we got a macro function.
Yeah, we love it. But like that, I don't think is important as the actual function itself, because that's what's doing the work.
This just adds it to some queue and some scheduler.
So get hash. Does this have the data? The event has the data, right? The event has iterate, has a callbacks, notify governance object. Yes. So notify governance object. Yes. So that one should have the data.
Right. And the thing that we were looking at before
is that
it
then
had
that
access to it, right?
Back around. Yeah. Oh, you went too fast for me.
So this one is a shared pointer to object. So this has the data. We can do get hash, but we still have
raw governance object. Here. Boom. That's it.
Raw governance object. There you go.
That's it. So serialized function, but then what the heck is SS? That's
a stream, which is CData stream. And
I think that's a TCP. I think it's TCP. I think it's a TCP stream.
Well, the stream, I think the data being written, it goes to the serialize, right? So it's just writing the data in.
So it's like it's a fancy way to call the serialize function rather than calling the serialize function.
Yeah.
Okay, so begin size message raw object. Okay, there it is. Send ZMQ message, message raw G object, and then SS. So All right, there you
Yeah.
go, right there. So that's what we need to know for certain is what SS is receiving in that instance. So however you did it for the other one, you do it for this one. Boom, we've got the serialization. And then we already have a send ZMQ function, so we just send it over ZMQ. So, I mean, easy peasy lemon squeezy. Why not submit something through 3 different channels and have 3 different types of network protocols handling it?
I honestly have no idea. Why not 4?
Should have
Why
taken
the
the
three?
hash of the hash and broadcast it one more time.
That's what I would have done.
All right, so that's it then. So, all right, so that's the part that I didn't find was the actual object. So yes, so we need to do the blockchain broadcast. We need to do the inventory broadcast over P2P. Blockchain broadcast can be done over RPC or Insight. And then we need to do the ZMQ broadcast, which has to be done over ZMQ. But the question is, I would like to see send ZMQ message. Who is it sending it to? Is it sending it to any full node or is it sending it to master nodes? I think we should just send it to the master node.
That would be the safe way to go since master nodes are full nodes. I did see a comment above one of those function calls, or actually, it was above the macro, and it had some text. There was a comment that said why they were doing it this way. I don't know if you guys caught that.
Okay.
Did not.
Which macro were you talking about? Do you remember? This one?
I no. There were like
Use a
3 or
macro
4
instead of a
lines
function.
of comments above it. Anyway,
Okay.
you can check in the stream later on when we.
Look, any C++ code that you can read wasn't written by a good C++ developer.
It had something to do with logging. Like we're doing it this way so that it can log in a certain way. I don't know, but
Okay.
anyway, it's there if you guys want to review the stream.
Well, isn't that? I thought that was the one I said.
Yeah,
Is what you're looking at?
that's what I was looking at. Yep,
Yeah.
right there.
Okay.
Yeah. It's good that they save those CPU cycles when they call the get hash function 6 times.
Yeah.
Anyway, I'm just saying that there was some documentation on why they did it that way.
Yeah. I actually don't know what this means. Instead of a function for conditional logging. Okay, so yeah, is this an optimization where like it won't get put in?
It
based
saves
off of
it saves a evaluate and jump. Because what they would have had to do is put if debug enabled print the logger. So by having a macro, you don't have to have an if statement. That's pros at work.
I mean, yeah, if you have a constant, that's one of the optimizations compilers can actually do very well. Which is, if it's always true, then if it's trivially true, then the compiler will usually get it right.
Yeah, we can't muddy this up with if statements. We got hashes to mine.
Okay, so AJ,
Let's go.
you found the answer to your question, I guess, about those 3 different things that you had to publish.
Yes.
We did want to go in here and see if it was going to a master node or not, or just any node. So let's look at this. This is the ZMQ send multipart. This is the internal piece of send ZMQ message. Okay. So if we want to read this, send 3 parts, command end data, and a little endian 4-byte sequence number. And that's this message sequence here.
Where did psocket come from?
That is a void pointer.
Okay, well then maybe
it's given a null pointer right here.
I was expecting from its name that it was a pointer to the socket that it's writing to. But
seems reasonable.
Must not be it then.
Do something like this. So yeah, psocket equals ZMQ
P
socket.
context. So P context would be
that's
another void pointer.
What we get from initialize. which is it's used right here. And this p context is also a void pointer. Wait, was that? Yeah. So it gets set right here. I'm not getting any help on this one.
It's
Okay. I don't.
Look for where the p context is used to. It had like a get address there just a second ago. I don't know what just happened, but there was a get address. Okay, is ready. Get address. Set socket. So this is C code. It's calling out to libzmq. So it's creating a ZMQ pointer from C, and now it's doing set sock opt and outbound message, size of message. So there's probably going to be something else where it's taking psocket as the first parameter and setting the IP address of whatever. ZMQ bind, address C string. There you go.
Okay.
So address is what it is binding to. Where did it get address from? I have a feeling that this is not going the direction that's helpful. I think because I think what we're going to find is it's just contacting its local ZMQ service itself, and it's not actually. I think this may not be the part where it contacts a peer. It could be the part where it contacts a peer, but in any case, I think if we just, let's see, how do we have to do this? Because ZMQ does have a password on it, but regardless, we can figure it out. If we run it on our own full node and we proxy it just like we proxy the P2P messages, and we submit the ZMQ broadcast to our own node, since we know full nodes can send this message, we have reason to believe that our own full node would be able to broadcast the message to whatever it's broadcasting to.
Okay. Well, yeah. So I guess we looked at everything we wanted to look at in here. I don't think we think we're going to need to learn that much more from this right now. So, yeah, I guess. So, did we answer the final question that you were interested in, AJ?
I believe so.
Okay.
We submit this 3 different times as an op return to the blockchain, as a hash inventory message, and as a ZMQ broadcast. And I believe that we know how to do all of those things. So if you get the serialized form of it, then we can go from
there. We got it. Go from there. We'll see how far we can get.
Yeah. But the ZMQ stuff, let me see if I can find this real quick. -NPC2. Okay. This is where we have that one. -core -.conf. ZMQ. Okay, ZMQ, it appears, does not have a password. So ZMQ appears to be public. RPC has a password. P2P does not have a password. ZMQ does not have a password, if I'm reading this right. I could be reading it wrong. Let's see. I'd have to go look at I don't even remember which project we use ZMQ for. I know that we've used ZMQ before. Might have been for one of the merchant projects that is in limbo. That makes me sad. The merchant project is the most important project that we've ever worked on in terms of actual long-term Dash goodness, but it has to always take a back seat to things that get people's attentions for things that they're interested in right now.
Mm-hmm.
Because if we actually have merchants able to accept money and being able to spend money, then we have an economy. As long as we keep spinning our wheels on all of this technology. Granted, a lot of this was built, like all the core stuff that we went over, the dash join, the dash, or not dash join, the dash RPC, the dash TX, dash keys, dash phrase, all of that stuff that we went over earlier, all of that is necessary in order for merchants to be able to do stuff. Because the alternative is that the merchants have to compile C++ code into their website, which is not going to happen.
All right. So
Yeah, is there a WordPress plugin for that?
there are WordPress plugins for various crypto stuff. Haven't looked into them recently, but I know they exist. All right. So we're at a good stopping point for now.
I'm going to say yes.
Okay.
Thanks everybody for joining in. See you next time.